All right, well, welcome back. So in this section, we're actually going to be starting up a conversation of looking at a bunch of different properties of graphs of functions. The first of which is going to be this exploration of looking at where a graph is going to reach its maximum or its minimum point. In this case, this is going to become a really important tool as we move into the world of looking at optimization problems. It's this notion of if I want to maximize revenue or do something like this is really going to simply be a question of looking at where a function reaches its max point. Likewise, I'm going to have this question of where is something worst, and that's going to be this notion of looking at where a function reaches its minimum value. So in this section, we're going to be looking at kind of building up the guts so that when we come back to these optimization questions, we simply know how to apply these tools that we learn in this section and then start attacking a variety of different applications. So to start this conversation, we're just going to look at a really kind of random and strange looking graph. In this case, it's just some green curve that I sketched out. And the question is simply going to be, where is this thing interesting? And typically humans are pretty good at looking at a graph and identifying some weird things that actually take shape. So in this thing, the first thing that you might start to notice, mainly because we've been looking at this or talking about this idea of max points, is that if you look at this graph, you can probably identify 3 points where this thing reaches a maximum. In this case, one of them is going to be this point up here. You can see that it appears to be this overall high point of this graph. There's going to be an interesting point happening right here, and there's going to be an interesting point occurring there. So in this case, you can see that this graph is actually going to have 3, in a sense, max points. What I'm going to refer to these things as is I'm going to call these things relative maxes. So if I go ahead and actually say this is a relative max, there's going to be a relative max there, there's going to be a relative max there, and there's also going to be one up here. Okay, so in this case, I'm going to use this notion of relative max or local max, depending on the author or the book that you're looking at, to talk about this idea that I have this point, this kind of idea of being on top of a mountain peak. The idea is that it's this idea that it's locally a max, or this kind of in a small window around this thing. This point right here is actually the high point. If you think about these as being mountain peaks, if I were to kind of walk up to the top of this mountain, if I'm standing right here, yay, hooray, I made it to the top of a mountain, you can say, yes, I'm on top of a mountain. It may not be that I'm on top of the biggest mountain, but I am in fact on top of some mountain. So that's why we use this notion of relative or local in this case, is that, yes, I'm on top of a mountain. I might not be the biggest mountain, but I am in fact on top of one of these things. Okay, so along the same lines, I can talk about, instead of relative max points, I can actually talk about relative min points. You can see that down here, it looks like I'm at the bottom of one of these valleys, and at this little point right here, I'm also at the bottom of one of these valleys. So in this case, I have 2 relative mins. A relative min, there's going to be one right here, and there's going to be one right there. So I have 3 relative max points in this graph, and you can see that I actually do in fact have 2 relative mins. But if you're looking at this thing, you might say, hey, wait a sec, there's this point over here that appears to be lower than either of those 2 min points. And that's actually correct. You can see that over here, this point is actually the lowest point in this graph. Where it's coming from, though, is a slightly different situation. What's actually happening in this graph is that I'm starting over here, and I'm going to say I start at this point A. And what's going to be happening is that I'm ending over here at this point B. So this window, or this kind of graph, is only living on this interval from A up to B. So these points over here at A and at B, they actually get a special name. They're referred to as the endpoints of this graph. So this is going to become the right endpoint. I have a right endpoint and I have a left endpoint. And you can see that some interesting things are going to happen. In this case, this point B is actually going to create the overall low point on the graph. And we're going to give that a special name. We had this notion of having relative mins occurring. Well, I'm also going to have a fancy name for what is the overall lowest point on the graph. And the word for that is going to be absolute. So over here, this is going to be the absolute. In this case, it's going to be the absolute min. So overall, this entire graph, this is the lowest point that actually takes shape. Therefore, it gets this fancy name of being absolute. Well, if you look at it, I actually have one of these absolute max points, which is going to be the top of this little mountain peak over here. So I initially identified this point as being a relative min, but in this case, what it actually is going to be the absolute max. So it initially was a relative max, but now I'm actually saying that this thing is even cooler. It's actually the absolute max for this graph. So in this case, I have an absolute min, I have an absolute max, I got a couple relative mins in the middle, I got a couple relative maxes in the middle, and I have a few other kind of interesting things that are occurring as well. There is this kind of weird little squiggle that's actually taking shape. If you look at this, this is actually going to be a point where the derivative here is equal to 0. And that's a really interesting thing, because if you look at where all of the other points where the derivative is 0, that's actually identified as something else. You can see that right here where I have my relative max, there's going to be a derivative being 0 there. There's also going to be a derivative 0 at that relative max. This relative / absolute max is going to have a derivative of 0. Over here I have a derivative of 0 as well, and actually at this point I have that f prime is not even defined. So what's weird about this point over here is that I have this idea that I actually have a derivative that's 0, but it's not a max or a min. And we're going to see in a few sections kind of later that this point is actually going to be something else. So for right now, it's going to be this notion that it's a critical point. It's this idea that the derivative is 0 there, but it's not a max or a min point, which is kind of a weird situation to occur. This idea that these maxes are really easy to see. I have this nice horizontal tangent line. Everything is great. Over here I have this horizontal tangent line. Over here I have this kind of too many tangent line situation where that kicks out this idea of having relative mins. But in this case, neither of those things actually occur. What else is kind of weird about this graph is that actually the absolute minimum point did not occur at one of these points where the derivative was 0. It actually occurred at one of our endpoints. And that's going to be also kind of an interesting situation that occurs. This idea that sometimes a graph can actually achieve its max or its min just by looking at the boundary points in this situation. And that's exactly what happens in this case, is that I have a bunch of weird things happening, kind of identifying this idea of a max, there's a min, there's a couple weird things that are actually